Let's start this video with a look at the number 0.25, a number that is definitely greater than 0 and less than 1/2 and definitely less than 1/2. 0.25 is equal to the two other numbers on your screen, and we could look at 0.25 written as a fraction, 25 over 100. Likewise, we could turn this into an equivalent fraction by multiplying by the exact same number in the numerator and the denominator, in this case 10, to get an equivalent fraction. We could do that again and get a third equivalent fraction, which is very convenient because our decimal system is based on numbers like hundredths. You may have heard this called the hundredths place before, thousands place, and the 10,000ths place. We learned in video 4 about the reciprocal relationship between multiplication and division, and that's why you can divide by the exact same number in the numerator and the denominator to get an equivalent fraction. And if you notice, the 25 here would be considered the GCF. You may have heard of that concept. That's the number you use to divide to reduce a fraction, as long as you do it to the top and the bottom by the same number. Indeed, 0.25 is equal to 0.250 and is equal to 0.2500. It might surprise you, though, to know that you could put zeros before the decimal and you're not going to change the value of that number. If you did obviously want to change the value of the number and you wanted to make this a smaller number, you're going to have to sneak a 0 in between the decimal and the 2. That's the only way you're going to change the value of that number. A lot of students struggle with the fact that all these extra zeros that way and all the zeros before the decimal don't change the value of this number. But you can change it, again, by sneaking in a 0. And we'll talk more about this in video 16, about this relationship, about creating a smaller and smaller number here. For now, can you complete the two following fill-in-the-blank patterns? You have 5 seconds to press pause on your screen if you'd like some extra time before the solutions are revealed. Take 5 seconds to try to fill in the blank. Hopefully you thought that the answer was 4,000. And indeed, these are all equivalent fractions. And again, I'm not going to write times 10 for all of them, but I think you get the idea here that all of these are equivalent. And of course, all the decimals are equivalent as well. Second question, take a look at all those equivalent fractions, and can you decide what would be the answer for all of those fractions reduced into simplest terms? What number over 5 would all of those fractions reduce to? Take 5 seconds, think about that. Okay, well, hopefully you considered that the answer here, if you reduce, 4 divided by 2 is 2, 10 divided by 2 is 5. Notice it does reduce to 2/5. Here the GCF would be 20. Here the GCF would be 200, and obviously here the GCF, the number you would reduce by, would be equal to 2,000. Either way, all four fractions are going to reduce to the same number, and that is 2/5.